Hi students, myself Kale SL, Rayat Shikshan Sanstha's RBNB College Rampur. We see here 11 Science Mathematics Part 2, lecture number 8, chapter number 1st, complex number, exercise 1.3. In the previous video lecture, we have completed here exercise 1.1, and here in exercise 1.3, question number 1 to 4 completed. Now today here we start question number 5. So let us see here question number 5. Express the following in the form x plus iy. This is the question number 5, and the first example is here root 3 in the bracket cos of pi by 6 plus I sin of pi by 6. We have to express this in the form x plus iy. X plus iy means the complex number, we call it as a z. So given problem we call it as a z. Let z is equal to root 3 in the bracket cos of pi by 6 plus I sin of pi by 6. We know that here pi by 6 means 30 degree. We have seen in the first chapter of the paper number first, angle and its measurement, degree measure and radian measure. So pi by 6 is the 30 degree, pi by 4 is 45 degree, pi by 3 60 degree, pi by 2 90 degree, pi 180 degree. Now here the table of sine and cos is here. For 0 degree, pi by 6, pi by 4, pi by 3, pi by 2, I have written here. So now what is the value of cos of pi by 6? It is root 3 by 2. Cos of pi by 6 is, so it is root 3 into cos of pi by 6. From the table it is root 3 divided by 2 plus I into sine of pi by 6. Sine of pi by 6 here 1/2. So 1/2. And so we get here, we multiply by root 3 inside the bracket. So root 3 into root 3, that is 3 divided by 2 plus root 3 into 1, that is root 3, and divided by this 2 into I. So this is the solution, 3 by 2 plus root 3 by 2 into I, which is in the form x plus iy, which is in the form x plus iy or yi. We may write here I from this side or from this side. So we have completed this first problem. Now the second problem, root 2, second problem here, root 2 in the bracket cos of 7 pi by 4, cos of 7 pi by 4 plus I sin 7 pi by 4 plus I sin 7 pi by 4. So firstly call this as a z. So z is equal to root 2 in the bracket cos of 7 pi by 4 plus I sin of 7 pi by 4. Now this angle 7 pi by 4, this angle, it is not the standard angle, which is not in the table of sine or cos. So how to find this 7 pi by 4, trigonometric ratios for 7 pi by 4? So firstly we find cos of 7 pi by 4 and sine of 7 pi by 4 separately, and then we solve this z. So consider here cos of 7 pi by 4. Cos of 7 pi by 4. We write this 7 pi as cos of 7 pi as 8 pi minus pi. 8 pi minus pi, that is 7 pi divided by 4, and now divide separately. So we get here cos of 8 pi divided by 4, 8 pi divided by 4 minus pi divided by 4, and so it is equal to cos of here 2 pi minus pi by 4. We divide by 4 to 8, 4 ones are 4, 4 2s are 8, so 2 pi minus pi by 4. Now we have to find the value of cos of 2 pi minus 4. So if we consider here coordinate axis, this is a x and y axis, and this xy axis divide the plane into 4 quadrants. We know this is the first quadrant, second quadrant, third quadrant, fourth quadrant, and now here cos of 2 pi minus, Here it is 0 degree. Here 90 degree, 180 degree, 270 degree, again 360 degree. In the radian measure, here it is pi by 2. Here pi. Here 3 pi by 2. And here it is 2 pi. Get it? In radian measure. In degree measure we know 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. Here this one part is of pi by 2 radian. This pi by 2, this pi by 2, 180. Again 1 pi by 2, 2 pi by 2, here 3 pi by 2. 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. 4 pi by 2 means 2 pi. Get it? Now 2 pi minus, it lies in the fourth quadrant. 2 pi minus lies in the fourth quadrant. Here it is 2 pi, here pi. So here pi minus, here pi plus. Here 2 pi minus, here 2 pi plus. And now 2 pi minus angle, 2 pi minus lies in which quadrant? Fourth quadrant. And in fourth quadrant, cos and sec is positive. Cos and sec is positive and remaining 4 are negative. We know this. Here all are positive. Here sin and cosec is positive. Here tan and cot is positive. Here cos and sec is positive, means cos is positive. Here we have to use the formula for cos. So we consider the sine of cos. Cos is positive in this quadrant. And so we get here value as cos of pi by 4. We remove this 2 pi and so it is cos of pi by 4. But we have to consider the sign convention. And sign convention is cos ratio is positive in the fourth quadrant, also sec is positive and remaining 4 are negative. So we take here positive and then we remove this 2 pi. This is the formula we learn in the paper first. So cos of pi by 4 now. Cos of pi by 4, 45 degree, pi by 4. And cos of pi by 4 is 1 upon root 2. Get it? So here we write 1 upon root 2. Now we find here sine of 7 pi by 4. Sine of 7 pi by 4. Sine of 7 pi by 4. So we write this 7 pi like 7 pi as previous. Here 8 pi minus pi. 8 pi minus 1 pi, that is sine pi. 7 pi divided by 4. So it is equal to sine of, divide separately. So 8 pi upon 4 minus pi upon 4. Now here 4 ones are 4, 4 2s are 8. So sine of 2 pi minus pi by 4. Now here sine of 2 pi minus 4. It also lies in which quadrant? Fourth quadrant. Get it? And now here sine is negative in the fourth quadrant because cos and sec positive, remaining 4 are negative. So sine is negative, so we take here negative and then here cos of pi by 4. We remove now this angle. So sine of pi by 4 now again here it is 1 upon root 2. So here minus sign as it is and 1 upon root 2. In this way we find the value of sine of 7 pi by 4 and cos of 7 pi by 4, as 7 pi by 4 is not the standard angle. We have not the values in the table. And therefore we write this Z as Z is equal to root 2 in the bracket cos of 7 pi by 4 as 1 upon root 2. And here plus sign, here plus I, and sine of 7 pi by 4 is minus 1 upon root 2. So we write here minus 1 upon root 2. Get it? And multiply by this root 2 inside the bracket. Root 2 get cancelled, here 1. This plus minus become minus. Again here root 2 get cancelled. 1 into I, that is I. So here it is 1 minus I. Z is equal to 1 minus I, which is of the form. Which is of the form x plus iy. Get it? So this is the solution of the second problem. Now here third problem, solve yourself. The problem of third is use this method. We have given here cos of minus 5 by 6 and cos of sine of minus 5 by 6. So here a negative angle, we have to use the concept of negative angle. So let us see here third problem also. 7 into cos of 7 in the bracket cos of minus 5 pi by 6 minus 5 pi by 6 plus I into sine of minus 5 pi by 6. Firstly call this as Z. So let Z is equal to 7 in the bracket cos of minus 5 pi by 6 plus I into sine of minus 5 pi by 6. Now we have to find the value of cos of minus 5 pi by 6 and sine of minus 5 pi by 6. So let us see cos of minus 5 pi upon 6. And now here firstly use the formula. Cos of minus theta. We have seen cos of minus theta is equal to cos theta. We have seen in the trigonometry of paper first. Second topic, trigonometry first. The formula as cos of minus theta is cos theta and sine of minus theta is equal to minus sine theta. These are the formulas for negative angle. So use here cos of minus theta. Cos of minus theta become plus, that is cos of theta. Theta here 5 pi by 6. Get it? So we write here this 5 pi by 5 pi. So cos of, we write this 5 pi as a 6 pi minus pi. 6 pi minus pi divided by 6. And so it is equal to cos of, now divide separately. 6 pi upon 6 minus pi by 6. We divide by 6 separately. 6 get cancelled. So cos of pi minus pi by 6. Now see here, pi minus pi by 6. Here it is pi. Here pi. Here 0 degree, pi by 2, pi 3 pi by 2. Okay. Here pi, and pi minus means it lies in which quadrant? Second quadrant. It lies in second quadrant. And in second quadrant, sine ratio and cosec ratio is positive. Remaining 4 are negative. So here cos is negative in the second quadrant. So we take here negative. Get it? We take negative and we remove this now angle this pi. So now here cos of pi by 6. Cos of pi by 6. It is the formula cos of pi minus pi by 6, that is equal to minus cos of pi by 6. And now here minus cos of pi by 6. Cos of pi by 6 means 30 degree. Cos of pi by 6 is root 3 divided by 2. So here it is root 3 divided by 2. Similarly we find here sine of minus 5 pi by 6. Sine of minus 5 pi divided by 6, and we know that sine of minus theta is minus sine theta, so this is equal to minus sine of 5 pi by 6. So it is equal to minus sine of, we write this 5 pi as a 6 pi minus pi divided by 6. We adjust this number so that while we take the division, then we get the angle either pi or 2 pi. When we get here pi, if we take here 6 pi divided by 6, we get pi. So we take here 6 pi minus pi. In the previous example, there is 7 pi divided by which number? 7 pi upon 4. So 7 pi means at that time we take 8 pi, because when we divide 8 by 4 we get 2 pi. So 2 pi is on this side. So when we divide by denominator to numerator, first number should get either pi or 2 pi's, and for that purpose we adjust this number like this, 6 pi minus pi upon 6. So it is equal to minus sine 6 pi divided by 6, that is pi by pi, minus here pi by 6. Take the separate division. And now here sine of 180 minus theta, sine of 180 minus theta, here pi minus lies in second quadrant, here sine is positive. So here this is the minus sign, and sine of pi minus pi by 6, it is sine of pi by 6. Okay, and so it is equal to minus sine of pi by 6 is 1/2. So it is 1/2, and therefore this z becomes z is equal to 7 into in bracket cos of minus 5 pi by 6. Cos of minus 5 pi by 6 is minus root 3 upon 2. So it is minus root 3 upon 2, and plus here plus I into sine of minus 5 pi by 6. I into sine of minus 5 pi by 6, here it is minus 1/2 into I, plus become minus, here plus and this minus 1/2, so it is minus 1/2 into I, and now multiply by 7 inside the bracket. So we get here z is equal to minus 7 into root 3 divided by 2, and here minus 7 into 1 7 divided by 2i, which is of the form x plus iy, which is of the form x plus iy. So this is the solution of the third problem. Now here next problem, fourth problem, e to the power pi by 3i, e to the power pi by 3i. Call this as z. This is in the exponential form, we know. So z is equal to e to the power pi by 3i. It is equal to r into e to the power I theta. We compare with exponential form, and therefore we get here r is equal to coefficient of e to the power I theta. Coefficient of this is 1, so r is equal to 1. And theta is equal to, theta is the coefficient of I, here coefficient of I is pi by 3, so theta is pi by 3. So the polar form of z is, polar form is given by z is equal to r in the bracket cos theta plus I sin theta. This is the polar form. Now we put the value of r and theta. So we get r is 1 and cos of theta is here pi by 3 plus I into sine of theta here also pi by 3. And now put the value of cos of pi by 3 and sine of pi by 3. Pi by 3 is the standard angle, that is 60 degree. In the table it is present. So we get here 1 into cos of pi by 3. Cos of pi by 3 is 1/2. 1/2 plus I sine of pi by 3 is root 3 by 2. Root 3 by 2. And so we get, when we multiply by 1, it is same, that is 1/2 plus I into root 3 divided by 2, and which is in the form x plus iy. So this is the solution of the fourth problem. Now here fifth and sixth problem you solve yourself. It is homework to you. We will see here next question. Question number 6. Question number 6 is here, find the modulus and argument of the complex number 1 plus 2i upon 1 minus 3i. 1 plus 2i upon 1 minus 3i. This is the question. We have to find the modulus and argument, and we have solved this question in question number 4. Express the complex number in polar form and exponential form, and fifth example. In the previous question we have solved this problem also. So here sixth problem we have solved. Now here we see question number 7. Convert the complex number. Convert the complex number Z is equal to I minus 1 upon cos of pi by 3 plus I sin of pi by 3, cos of pi by 3 plus I sin of pi by 3 in polar form, in the polar form. So consider Z. So let Z is equal to I minus 1 divided by cos of pi by 3 plus I sin of pi by 3. Firstly, write the value of cos of pi by 3 and sin of pi by 3. What is the value of cos of pi by 3? Cos of pi by 3 is here 1/2. Cos of pi by 3 is 1/2. We have seen in the table of cos and sin. So I minus 1 cos of pi by 3 here 1/2 plus I and sin of pi by 3 it is root 3 by 2. See here cos and sin and cos table. Here 0 degree, pi by 6 degree, pi by 4, then pi by 3. Only take here 30, 45 and 60 degree. Here it is 1 upon root 2, 1/2. Here 1 upon root 2 and here root 3 divided by 2. This value is here now. Root 3 divided by 2. This as it is 1 upon root 2 and this value here 1/2. And now see here cos of pi by 3. Cos of pi by 3 it is 1/2. Plus I sin of pi by 3. Sin of pi by 3 is root 3 by 2. We must know the table of sin and cos for the standard angle. And so here it is equal to I minus 1 divided by here denominator is 2, here also 2. So take the addition of this. So 1 plus root 3, this root 3 into I and divided by 2. Get it? Now we shift this to numerator. So we get here 2 into I, that is 2I minus 2 divided by 1 plus root 3I. Get it? So and now here this is the division of two complex number. In the numerator complex number, in the denominator complex number. So we write this complex number like this, minus 2 firstly, minus 2 and then this plus 2I and divided by 1 plus root 3I. And now here we take conjugate of denominator and multiply to numerator and denominator. Here instead of plus we take minus. So 1 minus root 3I and divided by 1 minus root 3I. And now take the product of numerator and denominator. So we get Z is equal to minus 2 into 1, that is minus 2. Minus 2 into 1 minus 2. Minus minus plus 2 into root 3I. 2 into root 3I. Then multiply by 2I to this. 2I into 1 plus 2I. Then 2I into minus root 3I. Here plus and minus, so it become minus. And 2 into root 3I into I. 2 into root 3I into I means I square. Divided by denominator. Use here formula a plus b, a minus b, that is equal to a square minus b square. Because those are complex conjugate of each other. So a square means 1 square minus b square. B means here root 3 its square and I, so I square. Get it? So Z is equal to here. Now this minus 2 and plus here take I common. that is 2 root 3 plus 2 into I, and here minus 2 into root 3 and I square is minus 1, and divided by 1 square is 1, minus root 3 square is 3, I square is minus 1. So Z is equal to, now we take here this minus 2 and this minus minus plus 2 root 3, because this is real part. So we collect real part, and then this is the imaginary part, plus 2, this 2 plus 2 root 3. We write 2 this and then 2 root 3 and I. This write also in one round bracket, divided by here 1 minus minus plus 3 into 1, 3. 1 plus 3, that is 4. Okay, so divide separately to real part and imaginary part. So we get here Z is equal to minus 2 plus 2 root 3 divided by 4 plus 2 plus 2 root 3 divided by 4 into I. Okay, so if we take here 2 common and divide to this 4, then 2 2s are 4, here also 2 2s are 4. Firstly take 2 common and then divide. So we get here Z is equal to here minus 1 plus root 3 divided by 2. Take 2 common and divide to this 4. Here also 1 plus root 3 divided by 2 into I. Okay, and now compare with A plus IB. This is equal to, suppose, A plus BI. What is A and B? A is here. A is equal to minus 1 plus root 3 divided by 2. And B is equal to 1 plus root 3 divided by 2. This is the value of A and B. Now here we have to convert this into which form? Polar form. Okay, so we have to find R and theta. R is equal to under root of A square plus B square, and theta is equal to tan inverse of B upon A. So we find R. R is equal to under root of A square plus B square. Okay, so it is equal to under root of A is here minus 1 plus root 3 upon 2, minus 1 plus root 3 upon 2 bracket square, plus B is here 1 plus root 3 upon 2 bracket square, and we have to solve this. So this is equal to under root of, we expand this using the formula A plus B bracket square, A square, that is minus 1 square is 1, plus 2 into minus 1 into root 3, that is minus 2 root 3, and plus root 3 square, that is 3, and divided by 2 square, it is 4, plus here also expand using the formula A plus B bracket square, A square, 1 square is 1, plus 2 into 1 into root 3, that is 2 root 3, plus root 3 square, it is 3 divided by 4. Okay, so it is equal to under root of, here denominator same, so we write same denominator, and then take the addition of numerator, that is 1 minus 2 root 3 plus 3 plus 1 plus 2 root 3 and plus 3. This minus 2 root 3 and plus 2 root 3 get cancelled to each other. Now here 1 plus 3 4, here 1 plus 3 4, 4 plus 4 8, so it is equal to under root of 8 upon 4. So it is equal to 4 2s are 8, so under root of 2, R is root of 2. And now here we find theta. Theta is equal to tan inverse of B upon A. This is the formula. Theta is tan inverse of B upon A. It is equal to tan inverse of B, means here 1 plus root 3 divided by 2 divided by minus 1 plus root 3 and divided by 2. We remove these 2, so it is equal to tan inverse of 1 plus root 3 divided by minus 1 plus root 3, because these 2 and 2 get cancelled. Okay, this is theta. And now here polar form of Z is, therefore polar form polar form of Z is given by Z is equal to R in the bracket cos theta plus I sin theta. Okay, now put the value of R. R is here under root of 2. R is here under root of 2. So Z is equal to under root of 2 into cos theta plus I sin theta. I sin theta. This is the polar form where theta is equal to, because theta here not standard value, so we write theta as it is. That is where theta is equal to tan inverse of 1 plus root 3 divided by minus 1 plus root 3. This is the required polar form. So copy this solution. So in this way we have completed question number 7. Now we see here question number 8. Question number 8, for Z is equal to 2 plus 3i. For Z is equal to 2 plus 3i, verify the following. Very easy problem. First, Z bar to the bar. Z bar to the bar is equal to Z. Second, Z bar is equal to mod Z square. Third one, Z plus Z bar is real. Z plus Z bar is real. And fourth one, Z minus Z bar is equal to 6i or imaginary number. Their addition is real and their subtraction is imaginary number. So we have given Z. Z is equal to 2 plus 3i. Z is equal to 2 plus 3i. Z bar, here Z bar means conjugate of this Z. While we find the conjugate, we change the sign of imaginary number. Here imaginary number 3i, its sign is plus, so we take here minus. 2 minus 3i. This is Z bar. Now solution of the first. Z bar to the bar. Here Z bar we find. So take again its conjugate. Take conjugate of this Z bar. Means change the sign of minus 3i. Here it is plus. So 2 plus 3i. And 2 plus 3i is nothing but Z. So it is equal to Z. This is the solution. Now second one. Second one, here we find firstly mod Z. So mod of Z is equal to under root of a square plus b square. We know this. Here a is, if we compare this Z with a plus bi, we know here a is 2 and b is 3. So it is equal to under root of 2 square plus 3 square. So it is equal to under root of 4 plus 9. So it is equal to root of 13. Root of 13. This is the mod Z. Mod Z is root of 13. Square on both sides. We get mod of Z square is equal to 13. Okay. We call this as equation number first. Now we find Z into Z bar. Z into Z bar. So Z is here 2 plus 3i. Z 2 plus 3i. And into Z bar is 2 minus 3i. So 2 minus 3i. Take here product. So 2 into 2, 4. 2 into minus 3i, minus 6i. Now plus 3i into 2i, that is plus 6i. Then plus minus here minus. 3 into 3, 9. I into I square. Okay, this minus 6i and plus 6i get cancelled. So we get here 4, this minus 9, I square is minus 1. So it is 4 minus minus plus 9, 4 plus 9, 13. So Z into Z bar is equal to 13. We call this as equation second from first and second. From first and second, we get here Z into Z bar is equal to mod of Z square. In second it is 13, in first it is 13, so both left sides are equal. Now here third one, z plus z bar, take their addition. Third is z plus z bar. So put the value of z, z is 2 plus 3i, plus put the value of z bar, it is 2 minus 3i. Okay, this minus 3i and plus 3i get cancelled. So 2 plus 2, it is 4. It is real because here I is not present. When there is I, it is imaginary number or complex number. So here only 4, so which is real? Which is real. Now fourth one is take its subtraction, that is z minus z bar. Z minus z bar. So it is equal to put the value of z as 2 plus 3i and minus z bar is 2 minus 3i, its conjugate. So here 2 plus 3i, this minus 2 and minus minus plus 3i. Okay, this plus 2 and minus 2 get cancelled. So here this 3i and plus 3i, that is equal to 6i, and we have to show here 6i, which is the imaginary number. So these are the solution of question number 8. Copy this. Now here we will see the last question, question number 9 in this exercise. Question number 9. Question 9. If z1 is equal to 1 plus i, comma z2 is equal to 2 minus 3i, verify the following. Verify the following. So first one is z1 plus z2 bar. First one, z1 plus z2 bar is equal to z1 bar plus z2 bar. Okay. Second one, z1 minus z2 bar, z1 minus z2 bar is equal to z1 bar minus z2 bar. Third one here, z1 z2 bar, z1 z2 bar is equal to z1 bar into z2 bar. And fourth one, z1 upon z2 bar, z1 upon z2 and whole bar is equal to z1 bar divided by z2 bar. We have to show this. Okay. So now we have given z1 is equal to 1 plus i and z2 is equal to 2 minus 3i. Commonly we must know z1 bar and z2 bar for all problems. So let here solution, let z1 is equal to 1 plus i, comma z2 is equal to 2 minus 3i, and therefore z1 bar is equal to, take the conjugate of this, so it is 1 minus i. z2 bar, it is equal to 2 minus become plus 3i. Okay, now we solve first. So first one, z1 plus z2, firstly find out z1 plus z2. z1 plus z2, it is equal to 1 plus i and plus here 2 minus 3i. This is z1 and z2. Take the addition. 1 plus 2, 3 plus I minus 3i. I minus 3i means 3i minus I, that is 2i, and here 3i negative, so minus 2i. This is z1 plus z2. z1 plus z2. Now take its conjugate. So z1 plus z2 bar, it is equal to, change the sign of imaginary number, it is 3 plus 2i. Okay. Now find out z1 bar here, z1 bar here, z2 bar, take their addition. So z1 bar plus z2 bar, it is equal to 1 minus I plus z2 bar here 2 plus 3i. Here 2i, here 2i. So it is equal to this 1 plus 2, that is 3, and 3i minus I, that is plus 2i. So observe here, z1 plus z2 bar is equal to 3 plus 2i, and z1 bar plus z2 bar also 3 plus 2i. We call this as equation second. From first and second, z1 plus z2 bar is equal to z1 bar plus z2 bar. Now we see here second. second that is Z1 minus Z2 bar. So firstly find out Z1 minus Z2. So Z1 minus Z2. Now put the value of Z1, 1 plus I. Due to this minus sign, we put Z2 in the bracket. That is 2 minus 3i. 2 minus 3i. So it is equal to 1 plus I. This minus 2 minus become plus 3i. Okay. Now here 1 minus 2. 1 minus 2 that is minus 1. And plus I plus 3i plus 4i. So minus 1 plus 4i. This is Z1 minus Z2. Take its bar, means conjugate. So Z1 minus Z2 bar, it is equal to this minus 1 as it is, and change the sign of imaginary number. It is minus 4i. We call this as equation number 3rd, suppose. Now here take Z1 bar minus Z2 bar. Already we have find here Z1 bar and Z2 bar. Only take their subtraction. So Z1 bar minus Z2 bar is equal to, firstly write the value of Z1 bar, that is 1 minus I. 1 minus I. And minus Z2 bar write in bracket, that is 2 plus 3i. 2 plus 3i. Okay. So it is equal to 1 minus I. This minus 2 minus 3i. Now here 1 minus 2, it is minus 1. And minus I minus 3i, it is minus 4i. We call this as equation number 4. See here, equation 3rd and equation 4th, right hand side are same, minus 1 minus 4i, minus 1 minus 4i. Therefore their left sides are also equal. So from 3 and 4, Z1 minus Z2 bar is equal to Z1 bar minus Z2 bar. Now we see here 3rd, that is Z1 Z2 bar is equal to Z1 bar into Z2 bar. So firstly we take the Z1 Z2. So third from here, 3rd, and then Z1 into Z2. Put the value of Z1, that is 1 plus I. 1 plus I. Then Z2. Z2 is 2 minus 3i. 2 minus 3i. Take the product of these two brackets. So here it is equal to 1 into 2, 2 plus 1 into minus 3i, that is minus 3i, plus 2 into I plus 2i, and minus 3 into I square. See here, then we multiply by 1, 2 minus 3i, multiply by I plus 2i, and plus minus 3i square. So we get here 2, this minus 3i plus 2i, it is minus I, and minus 3 and I square is minus 1. And so it is equal to now this 2 and this plus 3, minus plus 3. This is real, this is real. 2 plus 3, that is 5. So it is 5 minus I. This is Z1 Z2. Now take its conjugate, and therefore we get Z1 Z2 bar is equal to, we change here the sign of I plus I. We call here equation number, suppose 5th. Equation number 5th. Now we take here Z1 bar into Z2 bar. Already we know Z1 bar and Z2 bar, only take product. So Z1 bar into Z2 bar is equal to, Z1 bar is 1 minus I. 1 minus I, and Z2 bar is 2 plus 3i. 2 plus 3i. Take the product of this 1 into 2, that is 2, 1 into 3i plus 3i. Now multiply by minus I into 2, minus 2i, and minus plus minus I into 3i, that is 3i square. Now here this 2 plus 3i minus 2i, that is plus I. Okay, here minus 3 and I square is minus 1. And now here this 2 and minus plus 3. Get it? So 2 plus 3, it is 5, and this plus I. So we call this as equation number now, suppose 6th. This is Z1 bar into Z2 bar. Now observe here 5th and 6th. Right hand sides are 5 plus I, 5 plus I. So their left sides are also equal. So we write here from 5th and 6th. From 5th and 6th. Z1 Z2 bar is equal to Z1 bar into Z2 bar. Now the last one, that is Z1 Z2 bar is equal to Z1 bar upon Z2 bar. Now see on this side, fourth Z1 Z2 bar. Firstly find out Z1 Z2. So Z1 upon Z2. Z1 is here 1 plus I. Okay. Z2 is 2 minus 3I. And it is equal to 1 plus I upon 2 minus 3I multiply by its conjugate of denominator. That is 2 plus 3I divided by 2 plus 3I. Now here take the product of numerator. 1 into 2 multiply by 1 to this, that is 2 plus 3I. Then multiply by I, so plus 2I. And plus 3I square and divided by product of these conjugates using the formula a minus b a plus b, that is a square minus b square. A means here 2, so 2 square, minus b means 3I, 3 square and I square. So it is equal to, now here 2 plus this 3I plus 2I, that is 5I, and here plus 3, I square is minus 1 and divided by here 2 square is 4, here minus 3 square is 9 and I square is minus 1. Now here it is equal to this 2 and minus 3. Here plus 3 into minus 1 means minus 3. 2 minus 3, that is minus 1. So minus 1 plus 5I divided by here 4 minus plus 9. 4 plus 9, 13. So it is equal to minus 1 upon 13 plus 5 upon 13 into I. This is Z1 upon Z2. Z1 upon Z2. Now take its conjugate. So Z1 upon Z2 bar is equal to, here change the sign, plus, so minus 1 upon 13 minus 5 upon 13 into I. Okay. And now here we want to find Z1 bar upon Z2 bar. We know Z1 bar, Z2 bar we have find. So now Z1 bar upon Z2 bar. Now put the value of Z1 bar. Z1 bar 1 minus I. 1 minus I. Z2 bar 2 plus 3I. 2 plus 3I. So this is the division of two complex numbers. So we multiply by conjugate of denominator to numerator and denominator, that means 2 minus 3I and divided by 2 minus 3I. Okay. Now take the product. 1 into 2, 2. 1 into minus 3I, minus 3I. Minus I into 2, that is minus 2I. Here minus plus 3I square divided by denominator. Here a plus b, a minus b. So a square means 2 square minus b square, b is 3I, 3 square into I square. Okay. So here it is equal to 2. This minus 3I minus 2I minus 5I. And here plus 3. I square is minus 1 divided by, here 2 square is 4 minus 3 square is 9. I square is minus 1. So it is equal to this 2 as it is. Here 2 and plus minus 3. These are two real parts. So we take their subtraction, 2 minus 3. 2 minus 3 is minus 1 and this minus 5I. And divide by this 4 and minus plus 9. 4 plus 9 means 13. 4 plus 9 here write 13. And divide by 13 to numerator and denominator. So it is minus 1 upon 13 minus 5 upon 13. Here 4 plus 9, 13, and divide by 13 separately to minus 1 and minus 5. And here I, we call this as equation number, here it is 6, so here it is 7th. Here 7th and here 8. So from 7 and 8, from 7 and 8. Observe here 7th equation and 8th equation, right hand side minus 1 upon 13 minus 5 upon 13I. Here also minus 1 upon 13 minus 5 upon 13I means same. So their left sides are same, and therefore we get here Z1 Z1 upon Z2 bar is equal to Z1 bar divided by Z2 bar. So highlight this solution, copy this solution. So this is the complete solution of the problem number 9th problem. So we completed here exercise 1.3. So today we stop here. Thank you.